Today we're going to be taking a look at the Rhesus Factor and hemolytic disease of the newborn. As a starting point, we have four main ABO blood groups depending on the types of antigens present on each red blood cell. For example, if someone's blood group A, they'll have the A antigen present, which is coded in green here, and if someone's blood group B, they'll have the B antigen, which is coded in blue. As well as this, there might be blood group AB individuals who have both A and B antigens, or there might be blood group O individuals who don't have either the A or the B antigens. Importantly, the letters next to each blood group correspond to the type of antigen present on each red blood cell. Now, aside from the ABO blood group, we also have something called the Rhesus Factor. Some red blood cells might possess something called the Rhesus antigen, and when this is present, it's referred to as a positive blood type. Alternatively, other individuals might have red blood cells which do not have this Rhesus antigen, and this is referred to as a negative blood type. We can therefore say that red blood cells can either be Rhesus positive or Rhesus negative depending on the presence of this antigen. This consequently gives us a total of 8 possible blood types, so we can have the ABO blood group, and they can be both positive or negative. When it comes to the concept of transfusing between different Rhesus groups, we have to be careful to make sure that the transfusion is compatible. To explain this, let's take a look at an example where we have someone who's blood group positive and they try to donate to someone who's a negative blood type. When these red blood cells are transfused across, you can see that they possess the Rhesus antigen, and normally this blood group A negative individual does not have this antigen present. Therefore, when the immune system turns up, it recognizes these antigens as foreign bodies, and therefore produces anti-Rhesus antibodies against these antigens. These antibodies bind to the Rhesus antigens and cause them to clump together in a process known as agglutination. We can therefore say that positive blood types cannot donate to negative blood types because of this agglutination reaction. Just for the sake of example, let's take a look at the reverse case. So if we have someone who's blood group negative and they try to donate blood to someone who's a positive blood type. In this case, when the red blood cells are transfused over, you can see that they do not have the Rhesus antigen present. They only have the green A antigen. If we look at the blood group A positive individual, it also has the green antigen present. So when the immune system turns up, it doesn't recognize anything as foreign, and therefore there's no immune response. To summarize this, we can say that blood group negative individuals can donate blood to both positive and negative blood types, because there won't be any associated immune reaction. Okay, so it seems like we can be careful when we transfuse blood between different Rhesus groups, but one situation where we might have less control is during pregnancy, and if the fetus is a different blood group compared to the mother. In particular, if the fetus is Rhesus positive and the mother is Rhesus negative, there can be a risk of something called haemolytic disease of the newborn. This situation can arise if we have a Rhesus positive father and a Rhesus negative mother who conceive to produce a Rhesus positive child. While there might be no risk to the fetus in the first pregnancy, there's a risk of this condition developing in subsequent pregnancies. To explain this in more detail, let's take a look at what happens in the first pregnancy if we have a situation where the mother is Rhesus negative and the fetus is Rhesus positive. In general, there should be no direct mixing of red blood cells from the maternal system and the fetal system. There should only be an exchange of nutrients across the placenta. However, there might be some cases or some sensitization events which result in blood mixing directly, and this can include invasive procedures, external cephalic version, trauma, and birth itself. In any of these cases, red blood cells from the fetal blood system end up crossing the placenta and entering the mother's blood instead. Because the mother does not usually have the Rhesus antigen, these newly transferred red blood cells are regarded as foreign by the immune system, and an immune response is launched against them with the production of anti-Rhesus antibodies. These antibodies again lock onto the red blood cells with this Rhesus antigen and cause them to agglutinate together, eventually destroying them over time. Now, importantly, even after all of the fetal red blood cells are cleared from the mother's system, there's still persistence of the anti-Rhesus antibodies in the maternal blood. And this occurs because of the memory function of the immune system. it remembers antigens it's faced before. While there's no direct damage to the fetus in the first pregnancy, the persistence of these antibodies can result in complications in subsequent pregnancies. So again, we have a situation, this time the second pregnancy, where the mother is rhesus negative and the fetus is rhesus positive. The antibodies formed from the previous pregnancy can now cross over the placenta and attack the fetal red blood cells, and this can result in agglutination and subsequent hemolysis. This entire process is termed hemolytic disease of the newborn. The condition can lead to an array of different symptoms including jaundice, severe anemia, hepatosplenomegaly, and significant fluid overload in the fetus. Okay, so how do we actually prevent this disease from occurring? Well, the answer actually lies in administering anti-D immunoglobulin. Again, the main issue with rhesus disease is that we have the formation of these antibodies against the rhesus antigen. So we have to find a way to bypass the normal immune response and prevent the memory of the antigen so that future pregnancies are not affected. In terms of when we would administer anti-D immunoglobulin, this would depend on the status of the mother and the fetus. From this table, you can see that if the mother is rhesus positive, we don't have to worry about an immune reaction with the fetus, because there will never be maternal antibodies formed against the rhesus antigen if the mother is rhesus positive herself. Therefore, in these cases, no action is required, and we don't have to administer anti-D. However, if the mother is rhesus negative, we should always assume the worst and assume that the fetus is rhesus positive. In any of these mothers, we should look out for sensitization events, and if they occur, we should give anti-D immediately after the event. If there's no sensitization event which occurs, we should still give anti-D to rhesus negative mothers at around 28 to 30 weeks of gestation. Once the child is born, we can consider giving further doses of anti-D if they're actually tested to be rhesus positive. To explain how anti-D immunoglobulin actually works, let's return to our original diagram here. Again, we have a rhesus negative mother and a rhesus positive fetus. Let's assume we have a sensitization event, so any of the following events listed here. There's direct transfer of red blood cells from the fetus into the mother's blood because of this sensitization event. Now, as soon as we recognize this sensitization event, we administer anti-D immunoglobulin. So this is represented as the green antibody here. These anti-D antibodies bind to the antigens of the transferred red blood cells and eradicate them from the mother's blood. And importantly, they don't cross the placenta, so they don't attack fetal red blood cells on the other side. As a consequence, by the time the mother's immune system turns up, there are no fetal red blood cells remaining on the mother's side, and therefore no immune response is launched and no maternal antibodies are formed against the rhesus antigen. This means that in subsequent pregnancies, there are no anti-rhesus antibodies, and there's no crossing of these antibodies to attack the fetal red blood cells on the other side. In essence, we have bypassed the entire memory function of the immune system in the mother, so they don't have any memory of the rhesus antigen ever crossing into the maternal blood. To finish off, we have a summary slide here which outlines the whole process of hemolytic disease of the newborn, and we also have a textual summary here which outlines the key points from this session. I hope you found this video helpful, and I'll see you in the next one.